Watch this one. This is called contact representation. Venn diagram representation is one of it. If any function, any Boolean function can be represented using Venn diagram or using contact representation. Contact representation means like this. I'll just explain you what it is. Every Boolean function can be represented with the help of serial and parallel contacts. So this is a contact, right? So serial contact means these two, they are in serial, right? Parallel contact means these, like this. So parallel means, I mean, in electric circuits, we are lucky that you didn't take electrical. Otherwise, I'll just tell you why computer science is so easy, or why you are lucky not choosing electrical. I still remember that I had a subject called as EDC, electronic devices and circuits, I guess. I don't remember the name of the subject also, and I think you too don't remember it. But then what I mean to say is that subject is so stupid. I mean, I should not be saying that, but the electrical subjects are so stupid that you will not really enjoy them. The logic behind them is too complex to enjoy. Yes, you could enjoy it, but for that you have to dwell into the subject a lot. But computer science is so logical that the CS, you could call it as common sense rather than computer science. That is what I feel. You know what? I still remember one question. Whenever I see such things, I just remember one question that I have answered in my EDC. There is something called as capacitor, right? This is a capacitor, and in the question there is a question where AC passes through the capacitor, but DC will never passes through the capacitor. How I answered it is, see, AC means alternating current, therefore it passes through the capacitor, right? And DC means direct current, which means it looks like a single line, therefore it is not supposed to pass, it will not allow it. This is what I have given in the logic. In my BTech exam, I still remember that this is what I have given it, and I don't know how I got 97 marks in that subject out of 100, and I don't know where I missed out 3. Maybe I'm not sure whether this question has got it, or whether the evaluator got it or no. Every question I did it like this only. I made up my own explanations and I have written it, and I have written it so neatly and in such a way that I think he might have got convinced that this is the right explanation. That is how I got 97. BTech examinations are really stupid. Okay, fine. So sorry for deviating. Now let's see this. What I mean to say is, every function can be represented using contacts. These are called contacts. And when I write the contacts like this, they are called serial contacts. And when I write the contacts like this, they are called parallel contacts. Now watch it. Serial contacts are performing AND operation. So if the current has to flow from here through this circuit, then definitely there should be at least one path, right? Either the above path or the below path. If the above path has to be formed, then A has to be closed. If the below path has to be formed, then both B and C have to be closed at once. Therefore, how can you know that current is passing through this circuit is, one is either A should be closed or both B and C should be closed. That is how I am writing it. So this circuit is so simple that you are able to write it directly, but there will be some complex circuits for which you might have to follow a procedure, an algorithm. I'll just tell you what the algorithm is in the next few minutes. Now you just answer this and then we can move on. This is not a kind of contact, it is a kind of logical question. AB, which of the following does this following circuit represent? Which means, what is this is representing? That is what they are asking. So if the current has to pass through this, either both A and B have to touch the on, or either both A and B have to touch the off. So touching the on is nothing but using the variable in its true form. Touching the off is nothing but using the variable in its complemented form, right? So if I have to touch, both A and B have to touch the on form, it is nothing but writing it as AB. If both of them have to touch the off form, it is nothing but writing it as A prime B prime. Therefore, the function represented by this circuit is AB plus A prime B prime. Got it? So this is how we could represent it. So let's see, if a complex contact circuit is given, then contact representation, how to convert it to the Boolean function. So let's see that. Identify the Boolean expression given by the following circuit. So this is circuit given, and now we have to identify the Boolean expression. This is a contact representation. So whenever such a circuit is given, you just follow the method which I am going to say. Now find the valid forward path. Forward path means we should start from input and go to the output. That is a forward path. Find the valid forward path, and then after finding all the valid forward paths, you perform the ORing. ORing means you just you put a plus. Find the forward path and then perform the ORing. Now there are two things you should be knowing here. One is I am saying that valid forward path, which means there could be invalid forward paths as well, right? And second thing is I am saying that there is something called as forward path. What is the forward path first? See this, forward path is any path starting from input and ending at output without forming a cycle. So anything that starts from here and ends at here without forming any cycle in the middle is called a forward path. And validity means no path should contain a variable in both true and its complement form. So if you have a, then you should not have a prime. Got it? So that is what the validity means. So just observe this. Identify the Boolean path. How to identify the Boolean path is first you find out the forward paths and then see what are the valid forward paths in that. I'll just take this example and explain you. So how many ways can you reach from input to output here? How many ways can you reach from input to output here? See, so one way is A, B, B, and then this one, right? Then how can I write it? A, B prime, C prime. This is a forward path, right? Or let's see other paths also. A, B, C. Which means I would have taken this path and I would have gone there, right? And what is the other path? I would have taken A, B, A, B, A, or I would have taken A. I think I have explored everything starting with this B. If anything is remaining, you please do it. I feel that I have explored everything here, right? So let me explore this one. A, B, C, right? A, B, C, I can go there. Therefore I get A, B, C, and now A, B, and again I can come down and again go there. A, B, A, B, A, or A, yes, A, B is over. Now A, C, see this, A, C, A, C prime, C, A, C prime, C. This is what I call as invalid. The reason is it is containing both C and C prime. So what is C concatenated with C prime? 0. So what is the relevance of C is concatenated with C dot C ANDed with C prime in this circuit is when you are saying that one is saying that C is on, other is saying that C is off. So simultaneously the same switch, even though they are located at different places, it means that whenever at the input, when you switch on C, both of them will switch on or both of them will switch off, which means even though I am writing the C prime and C here, you could think of it like this. There is a common switch somewhere and this is what you are operating. Depending on what this value is, all of them will be set at the same time. So if the value of C is 0, this will be 1, this will be 0, and this will be 1, like that. So depending on the value of C prime is also decided. Therefore just keep in mind that these two are not independent, both are dependent on each other, both are not mutually exclusive. So the value of the other one depends on what the other one is. Therefore a switch cannot be simultaneously on and off. It is saying that the switch has to be off as well as on. It is not possible, right? Therefore it is invalid. That is what I say by what I mean by valid and invalid. And now one path is A, C prime, C, which is found to be invalid. Other path is A, C prime, A, C prime, A. Now you could simply simplify it. So what is this? A. This you can all simplify it, right? And then you have seen that this particular one ABC and ABC is repeating. Therefore you can remove one ABC, right? And again it is AB and it is AB. So these two are repeating. Therefore both are AB only, right? Therefore you could remove this, right? So it is AB, ABC, a prime. So you can just, my intention is not in simplifying, so you could simplify later. It could be further simplified a lot. The reason is it is again AB and it is ABC, therefore AB plus ABC will be AB, so this one will vanish, right? And it is A prime, A, B prime, C, it is AB, and again A, C prime. So you could try to even minimize it, or you can leave it there. My intention is not just my intention is just to explain how this one can be represented or converted to a function. Okay, fine.